I'm going to show one example, and then you go back and work some of the other ones. So what is the volume? And I like to just make a little list off to the side. You don't have to do it as a list. We always know R, 0.0821. PV equals N RT. Let me move my N down, my R down. So these are the things. We need 4 of the 5 of these numbers. So it's telling us we don't know him, so we better have information to get the other 3. So P, we're going to just look for units. So I'm just reading this, blah, 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 blah. Oh, I see a mole unit. Ah, well, that's great. We have this, 2.5 moles. Okay, now I'm going to keep reading, 25 Celsius. Oh, that's a temperature. Okay, so not to get my head thinking too crazy, I just write this in to remind myself, I do need to go ahead and do a unit change, but I don't do it there. I just write it in to remind myself. And up here, 1.3 ATMs. Now I have all of the things I need for my equation. I've also seen people where they just like putting letters above the top. That's how I was originally taught to do it, and that might be helpful also, just looking at the units. But if you do this, make sure you make some little note to yourself that you need to change that one to Kelvin. And V is what you don't know. Also remind yourself you always know R because it's a constant. So our equation, it's listed above, PV equals nRT. But let's rearrange it for our V. You can go ahead and plug the numbers in this way and write it. It's just you've got more writing if you plug the numbers in and then rearrange it. So I'm going to rearrange it first for the V. So I want this one by himself. So I'm going to divide both of these by P. And that's going to give me that's going to give me V equals nRT over P. And then I just plug the numbers over in. So this is 2.5 moles times 0.0821, and the units on that are liters, ATM, moles, Kelvin, crazy units right there. And then this right here, you really can just put this in your calculator. You don't even have to take a second and figure it out separately. That's a little small, so I'm going to scooch this over just a little bit. And remember, the reason I have to do this is because I don't have the right temperature units. It's got to be in Kelvin to be able to solve this problem. Now I'm going to go ahead and put in my P, which is 1.3 ATMs. I'm going to bring up my calculator here, over to the side. Clear it out. And I'm just going to put my numbers in. 2.5, I just like to go across the top, times 0.0821 times parentheses. So it is 25 plus 273.15 parentheses divided by 1.3. I'm putting this in. You might think, oh, how am I going to do sig figs? Well, we have just 2 sig figs here. If you kind of glance through the other numbers, I've got 2 sig figs here. I don't have anything that's less than 2 sig figs, so I'm pretty good on just going with 2 sig figs. And so that answer is 47. And what's the units? Let's double check we're cool with our units. So let's just make sure. So here's our moles. So our mole is canceling there. And I did not write my K like I should have, but that was a Kelvin. So my Kelvin is on top and my moles are on bottom, so that cancels. And then here's an ATM and an ATM, and those cancel. So my unit that's left over is a liter, which makes sense because I was solving for volume. You might try reworking this problem. We definitely be going over it in class. I just want to show you an example of another way to set up these problems. And in this case, I've kind of got a piece of information hidden. So we have P, we have V, we have N, we have R, and we have T again. And R is our 0.0821, and you can go ahead and throw all those units on there. So I'm going to scroll through, and it says at what temperature. So the temperature is what we don't know. Here, that torr, that's a pressure unit, but remember, I always like to go ahead and write in, if I don't have the right unit, I go ahead and change it. You know, if you don't remember all the numbers, it's okay, but I got to go from a torr to an ATM. That's just my reminder there. So that's my pressure unit. My volume is 20.0 liters, so that unit is fine. Now, how am I going to get my moles? I know grams, and this is nitrogen gas. How am I going to get my moles, though? Well, I know from the periodic chart, and this goes also back to remember something is diatomic. Nitrogen is diatomic. So his molar mass is that 14.0067. So I'm going to say 14.01, and that's grams per mole. But there were 2 of them. So this is 28.02 grams per mole. Now I can get my grams to moles. I can say that I'm going to zoom in, 41.6 grams of N2, and then grams of N2 into moles of N2, 28.02 in 1 mole. And when I go and I fill those in, just like up here where I had this, and I just put it in, you can put it in like that. You don't have to go ahead and solve these individually and then plug them into the equation. It's a little bit more work that way. And if you don't remember this relationship here, this is the time that you would go back and find it. Some of this about brain flow, and don't stop yourself to go and find something. Just make a note, reminder like I did. And plug that in and see if you can solve it. And last but not least, here's a little hint on this one. Go ahead and try these problems on your own before you come to class. STP, remember that's that hidden way of saying that the temperature is 273.15 Kelvin and the pressure is 1.00 atms. Notice here this is moles, so that's in. And you already know R, 0.0821. And so you're finding your volume. All right, let's just move on to the next set of problems. I'll give another example on how to work these problems. And we'll finish with these ones. Well, I'll show you how to fill these to try to plug these in, and we'll actually do these in class. So these are great practice problems. If you can do these and plug it in, you're great for class. So I'm going to read this kind of carefully. It says it goes from 1 atm to this other atm. So from, that's your initial pressure, and then what it went to is your other pressure. Let's see, the temperature increases, again, from, that's your initial temperature, and then there's your final temperature. Then we have initial volume. Oops, wait, let me put that beside the actual number. And then this is what you're looking for. You can make a list of these on the side. I'm gonna put them in order. So it's like the left side and the right side. So P1 is 1.00 atms. V1, so I'm jumping over to him. It's a little further on the problem. That's the 12.0 milliliters. T1 is that 273.15 Kelvin. Then P2 is 5.00 atm. V2 is what we're looking for. And then T2 is the 350.15 Kelvin. Like before, we're going to take this problem and we're going to rearrange it so that it's solving for the variable that we want. Now, if you don't want to do it that way and you want to plug your numbers in and then rearrange, that's fine too. I'm just trying to save a little bit of time, just a little bit. So we're looking for this. That's the one we're looking for. So I'm going to cross multiply to get my T2 to the other side. So he's going to go over there and my T1's going to go that way. So I'm going to get P1 V1 T2 equals P2 V2 T1. Now I still need to get my, I'm looking for this V2 letter. So now I'm going to divide both sides by my P2 T1, P2 T1. And then these ones are going to cancel out. So I'm going to plug my numbers in. So I have 1.00 atms times 12.0 milliliters times, and then I'm going to zoom in a little. so that I have enough room, times my T2, make sure you're grabbing the right numbers from your chart, 0.15 Kelvin, divided by P2, which is my 5.00 ATMs, times, and then the T1 is the 273.15 Kelvin. Remember, this is that problem where everything just has to be in the same units. We don't have to be as particular because we don't have R values. So just as a note, my ATMs here cancel. My kelvins here cancel. And so I'm going to be getting an answer in milliliters. So as long as you glance at the problem to make sure that it says it wants it in milliliters. But as long as it's in milliliters, then that's fine. So let's go ahead and solve this one. So I'm going to go across the top, 1.00 times 12.0 times 350.15 divided by 5.00. Oops, sorry, undo. Divided by 5.00 divided by 273.15. Now, you could write it like that and solve it, or if you don't like doing it that way, you can also use a parentheses. You're not going to get the right answer if you don't use a parentheses if you're going to solve it like this. Do you see how now 273.15? You see how now I've got a multiplying on bottom? You got to have a parentheses if you're going to put in your calculator like that. How many sig figs? Kind of glance through those numbers. The lowest sig figs I'm seeing is a 3 sig fig. So I got to take this out, and it looks like this should actually be 3.08. But that's the number that we get. Notice it's in milliliters. And again, that's milliliters because this number over here came out in milliliters. So now you've seen an example on how to work that problem. You work all the other problems in the same way. Just make sure that your units are the same in all of your different situations. So we're going to go through and do this one last example. And I'm just going to make a list on the side to make sure that you've got what's what. So this right here, this is our row term. Let's see, 17 Celsius, that's our temperature, but don't forget it's got to be turned into Kelvin. This right here is our pressure, and don't forget that needs to be in ATMs. And it wants us to find molar mass, so it wants us to find this. You'll notice you can rearrange this equation so that it's solved for molar mass. If you know the molar mass of something, you can look at the periodic chart and you can figure out what it is. And let's bring the terms to the correct side. So I've got, let's see, we'll do a row. This is our 0.0847 grams per liter. Our P is that 760 torr. And again, I would just really quickly write this little note to myself to remind myself I got to change it, but I won't change it then. And then R, we know R every single time, 0.821. And this is liters, ATM, times moles, times Kelvin. And then T is that 17. And again, I'm just making a little note to myself, reminding myself that that should be in Kelvin. Last but not least, let's make sure that you get this rearranged correctly for your molar mass for when you're solving for him. So we want to solve for this term right here. So I'm going to cross multiply these bottom guys to the top left side. So I'm going to get RT times rho. And then I'm going to just divide both sides by P so that I've got my molar mass. And I'll just be plugging those numbers in. All right, and let's see if you can solve this one. Once you get this molar mass, compare that number to the periodic chart. You will find a match near the top of the periodic chart for what this gas is. And let's just double check this one right over here. Make sure you've got all the numbers in right. Again, this one wants to solve for molar mass. So this is our M, that's our grams. This is our volume. This is our temperature. And this is our pressure. So P equals 743.1 Millimeters of mercury, little note to myself, that's not in the right units. So millimeters of mercury into atms. And then my mass, and you could have done mass first, it's fine. 1.008 grams. This is fine to be in grams. My volume is at 296 milliliters. Now, this volume has got to be in liters. And then my temperature is 48 plus 273.15 Kelvin. So you can see the big deal in all of these problems is making sure stuff is in the right units. And then you're just going to plug it in. You know your R2, it's at 0.0821. Liters, ATMs, mole, Kelvin. And see if you can get the next one set up. Doing all of this before class is going to help so much.